GameSci.com. GameSci.com. Welcome to GameSci.com. I am Professor Chris Ferguson. GameSci is where we learn game programming and computer science at the same time. This is CS1, Intro to Computer Programming. This course is a series of 10 lessons, and this is lesson
Number 3, Selection or Control Statements.
Since we will be building a simple game piece by piece, it's best if you watch the videos in sequence. While we build a simple game, you will also learn object-oriented programming and the important concepts of computer science. I am Professor Chris Ferguson. Enjoy the course.
Hello, welcome to Selection or Control Statements. A selection statement is so named because it selects which code to execute. In some books, they call them control statements because they control the path the program takes. Let's start with the simplest and easiest of the selection control statements, the if statement. If something is true, I'm going to execute some code. And when it's false, I will skip that code. The best way to explain it is to illustrate it. So let's trace this programming code example. We're going to set up a variable score here, and you can see that score has the value 2 currently in it. So I'm going to do if score less than 3. Well, that's 2 less than 3, and 2 less than 3 is a true statement. When this statement is true, what's going to happen is we will select this code to execute and print out it is true. And you can see it is true came out on the output. It's as simple as that. When the condition is true, we execute the code between these curly braces. When it's done, it will fall through and continue on with the computer program. Now let's run this again, but this time let's set the score to 4 before we start. You can see I've updated the value score in the variable. It is now 4. Now when we run the if statement, it's 4 less than 3, which is a false statement. When this statement is false, what's going to happen? We are going to skip past this code and continue on with the program. It's called a one-way decision. When it's true, we will execute that block of code. When it's false, we will simply skip it. Fairly simple. Let's go again with score equal to 0 this time. So I'm going to update the variable score to 0. And when I run the code now, score you can see has the value 0 in the variable. When I extract it and do score less than 3, 0 less than 3 will evaluate to true. And when it's true, what happens? We go inside the code and execute system.out.println it is true. And you can see once again it is true is shown up on the output for a second time. Again, it's called a one-way decision. I'm going to execute that one block of code when the condition is true, or I'm going to skip it. Either way, I'm going to continue on with the program after the if statement. Any code that appears after the if statement will execute. It's that simple, folks. Let's go on to a upgraded version of this called the if-else statement. Again, the if-else statement is a selection or control statement. Some books, some computer science textbooks call these selection statements because it selects which code to execute. Other books call them control statements because they control the path the program takes. Either way, selection or control statement, the if-else statement is a two-way decision. You have two different options for the code to execute, and the best way to see it is by tracing the code. So let's start with 9 in the damage variable over here and 10 in the health variable. And let's see how this code works. 9 greater than 5 is a true statement. 9 greater than 5 is true. As you might suspect, we're going to go inside and execute the code in the if statement. Health equals health minus 3. And what happened here is we subtracted 3 from the health variable and it went down to 7. Do you see why it's called a selection statement? We selected this code to execute. What happens when we're done with the code in the if portion? When we're done with the code in the if portion, we skip past the else. This is a two-way decision. You will select one path and skip the other. So we skip past the else and continue on with the program. Let's start again, and this time let's set the damage variable equal to 2. What happens when damage is set to 2? Here's 2 in the damage variable at this point. We have 7 still in the health variable. Let's see what path this program chooses to take. 2 greater than 5 is a false statement. As a false statement, what's going to happen is we will not execute the if portion, but we'll go to the alternative else portion. So you can see by the line, because damage greater than 5 was false, we're going to go down and execute the else code. When we execute the else code, the health equals health plus 1 will go, and our 7 became an 8. This is called a two-way decision, and you can see it's taking the second path, the else portion, because the condition was false. The Boolean value up here evaluated to false, 2 greater than 5 was false, so it selected the else code to execute. And of course it continues on and finishes up the if-else station. If there was any code below this, it would execute. Let's try it again. Set damage equal to 13 this time and trace the code when a larger number is in the damage variable. So damage is set to 13. Our health still retains its previous value of 8. 13 greater than 5 is very much a true statement. As a true statement, it does what we would expect. It executes the if portion. When the condition or Boolean is true, we will select this piece of code to execute. Health equals health minus 3 will execute, and you can see the updated 5 in the health variable. When it's done with the if portion of the if-else statement, it will skip past the else and continue on with the program. One more time, and we'll wrap it up. Start again with damage variable set to 5, and let's trace what this code does. You can see the updated value of 5 in the damage variable. You can see the health variable now contains a 5 in it. 5 greater than 5 is a false statement. 5 is not larger than 5. So this comes out to be a false statement. What do you expect to happen when that statement is false? We expect it to skip the if and go to the else and execute the code in the else. When it executes the code in the else, it'll go inside this block. Everything between these two curly braces will execute when the condition is false. Health equals health plus 1. We've bumped the health variable back up to 6. So there you have it. There's 2 full examples of tracing the if-else statement through both paths the program could take. Do you see why it's called a two-way decision? It will select between one of 2 paths to execute. And that selection is based on this condition or Boolean value being true and false. When it is true, I will select this code to execute. When it is false, I will select this code to execute. Fairly simple and straightforward. That is the if-else statement. It's an upgrade to the if. Moving on, let's take a closer look at what produces the true-false answers. What produces a true-false answers is something we call relational operators. Now, some of these operators you probably learned in the 3rd grade. Things like the less than operator and the less than or equal to than operator, the greater than or equal to operator, and the greater than operator. Some of these might be new. The equal operator says if both sides are the same, return true. The not equal operator, if the 2 operands are different, return true. We'll see how they work by tracing the code. But one thing I can tell you about all relational operators is they all return true or false. When they return true false, they are excellent for use in an if-else statement. I'm also going to show something new here. When there is one and only one executable statement in an if-else statement, the curly braces aren't required. Now, I myself prefer to always put in the curly braces, but if there is one and only one executable statement in the if else, I am not required to use curly braces. Also, if there's one and only one statement in the else portion, I'm not required to use curly braces. So just to show you an example where you don't have to put in the curly braces, we'll run this without the curly braces. So let's go through this first. We'll set up 19 in the age variable, and we'll look first at the less than operator. So with 19 in the age variable, 19 less than 18 is a false statement. Always has been, always will be. 19 is not less than 18. Because that condition is false, what is the code going to do? Why, it's going to go straight to the else. It's going to go straight to the else to execute the else portion. And you can see it prints the word false onto the output, and a false showed up on our output. Pretty simple. Now let's illustrate the less than or equal operator. Once again, let's put an 18 in the age variable, and we'll look at 18 less than or equal to 18. 18 less than or equal to 18 is very much a true statement. Since they are equivalent, the equal portion will make that relational operator true. All relational operators return true or false, and in this situation, this operator is going to return true. As a true statement, you know what it's going to do. It's going to execute the if portion of the if-else statement. It's going to print line the word true, and true shows up here on our output. All of these are fairly simple. I'm just running through the examples to show you how all of them work. Let's do the greater than operator now. Let's replace the value age. Now, one of the reasons I'm showing you different values in the variables is I want you to understand that every time this code executes, it could take a different path. It all depends on what the value in age is and what the relational operator is. I need you to understand that this is what makes a computer programmable. It makes it programmable because every time this software runs, it could select or choose a different piece of code to execute. With 16 in the age variable and looking at the greater than operator, 16 greater than 18 is a false. So during this particular execution of the code, since the condition is false, it will choose to execute the else portion of the code, and we'll output the word false, and you'll see false show up here. Let's look at the greater than or equal to operator. We'll put 20 in the age variable, so at the time this code executes, we're looking at 20 greater than or equal to 18. 20 greater than or equal to 18 is very much a true statement. As a true statement, we'll select the true path. We'll output the word true, as you see it show up on the output down here. And of course, when it's done executing the if portion of the code, it will skip past the else. Look at that line right here. It never, I repeat, never executes both. It will select the if and skip the else, or it will select the else and skip the if. Let's look at the equal to operator. That's two equal signs right next to each other, and see how the code behaves with that relational operator. Here we set 17 in the variable age. And again, I'm changing these variable values to show you the dynamic nature of this code. Every time it executes, it can choose a different path based on the value of the age variable. So 17 equal to 18 is clearly false. As a false value in the true false Boolean operator, equal equal, as a false value, it's going to select the else path. The else path says execute the print line of false, and a false shows up on the output. Let's look at the not equal operator now. This is the last relational operator we'll be looking at. I hope you like this slide. Now, the code doesn't dynamically change its relational operator. I'm going through all the different 6 relational operators to show you how they behave and how they affect the if-else statement. Age now has the value 21 in it. So at the point this code executes, 21 not equal to 18 is very much a true statement. left operand is not equal to the right operand, so it returns a true. As a true statement, as you would expect, it comes in and executes the if portion of the code, and a true shows up on the output. And of course, when it's done with the if portion of the code, it exits the if else. Remember, it will only select one piece of code to execute. If it does the if portion, it will skip the else. That's my slide. That's all 6 relational operators. Keep in mind, relational operators return true false values, and those true false values could be used in if and if else statements to determine which code executes. That's the whole point of it, deciding which code executes. That's what makes a computer a programmable machine. Every time the software runs, it can decide to execute a different section of code. Let's move on to the next slide. I want to introduce something called a flowchart. A flowchart is a graphical representation of the logic of a computer program. Not everybody knows how to read code, so what flowcharts do is they provide a way for non-technical people to see what the code is doing. Flowcharts also provide a way for designing code, for determining how you want your code to execute. Whenever you type in a piece of code, there's 2 problems to solve. You have to solve the logic of the program. What is the sequence of commands I want to execute? And you have to solve the syntax of the problems. Am I getting all my curly braces, semicolons, and double quotes in the right spot? Well, by breaking that problem into 2 pieces, designing the code first to solve the logic of the problem, when you have a good design, you can then type in the code and only worry about the syntax. Let's see what a flowchart is and what a flowchart does by once again tracing some code. What I have over here is what I call generic or pseudocode. This is not executable code. This is not something you could type into an IDE and have it run. It's a generic piece of code or pseudocode that illustrates the example of an if statement. I'm going to draw lines here to show you how the if statement corresponds to the generic flowchart for the if statement. We already know if some true-false condition is going to occur, we're going to decide to execute this code or not execute the code. True-false statements in flowcharts always appear in diamonds because diamonds have these nice points on the edge we can label true or false. Anything that evaluates true-false, like a relational operator, always appears in a diamond in a flowchart. And that's what this arrow is showing you. This true-false condition is represented by that diamond in the flowchart. Now let's say that condition was true. If this condition was true, we're going to go inside and execute the statements. And that's what this red line is showing you. The condition was true, so I will take this path and execute the block of statements in the if code. When it's done, I will leave the if portion of the code and continue on with the program, and that's what this arrow is showing you here. After the block of statements executes one time, I will leave the if statement. Now let's run through this again and let's show the false path this time. What happens when this condition is false? I execute this code again, and this time our boolean or our condition is false. What happens when it's false? Well, first of all, we're in this diamond evaluating the true-false statement, and this time it comes out false. Well, we know when it's false in the code, we just skip the if block. We execute nothing. Over here on the flowchart, you can see it will take the false path out of the diamond, go this way, and skip the statement. What we're doing is we're graphically showing you that it's skipping that block of code, and that's exactly how we expect the program to behave. When the condition is false, skip the if portion of the code and continue on. There you have it. That's called the flowchart for the if statement. There's also a flowchart that represents the if-else statement. It's formatted slightly differently, but it's not a whole lot different. Recall that the if-else statement provides a two-way decision. It selects one of 2 paths to execute and will only execute one of those paths. Let's trace the code again. with arrows on the flowchart to show you what's doing. Here we have our true-false statement. We're going to assume this time it's true. True-false statements are always evaluated inside of diamonds inside a flowchart. So I'm going to evaluate this true-false statement and select the true path. When this if statement is true, I will execute the first block of code, the block of code within this set of curly braces, right there. That code says take this path out of my diamond and execute statement block number 1. When it's done executing statement block in the if portion of the statement, it's going to skip the else portion and continue on with the program. And that's what this arrow is showing you. I'm skipping the else portion. I will not execute the else code, and I'll continue on with my program after the if else statement. This path should be familiar to you now. If the statement is true, I will execute the first block of statements and skip the else. Now let's run through it on the false path. Again, we'll execute the if true false statement in the parentheses. This time we'll assume the result will be false. So we're here in the diamond evaluating the true false statement. What happens when the statement is false? We select a different path. That's why it's called a selection statement. It's a selecting different code. If the condition is false, we will go to the else portion of the code, and that's what this arrow is showing you. Go select the else code to run. That's what this line is showing you. Take the line labeled else and follow it to execute the alternate block of statements. So this block of statements is equivalent to this block of statements over here. After the else portion executes, we will leave the if else statement and we're done with the if else, and that's what this arrow is showing you there. That's a flow chart. Let's wrap it up and move on. Let's look now at the else if statement, which really isn't a new statement. What I'm going to do is immediately follow an else statement with another if. I'm going to sort of chain or domino these things together so that several if else statements are run back to back to back. The best way to show it to you is to trace it. This, once again, is a specialized form of the if-else statement where I'm combining several of them into a block of code. Let's start with a damage variable that contains 12 and a health variable that contains 100 and trace what this code does with those variable values. With a damage equal to 12, 12 greater than 10 is very much a true statement. As a true statement in the if portion, we expect this code to select the if code to execute. So we'll do a health equals a health minus 8 because we received high damage. We're going to subtract a lot from the health point. And our 100 in the health variable just shrunk to 92 in the health variable. Take a lot of damage in a video game, you expect your health variable to go down. And that's what it did. Now, what happens after we execute an if portion of an if-else statement? It skips the else. Now, what you have to understand that this if is attached to that else. So if this if is true, we have to skip this else. What you may not see is that all of this code is part of that else. Remember, if there's one and only one statement after the else, you don't need curly braces. So rather than putting a curly brace here, I immediately put a single if-else statement. And what I'm going to do is skip this entire if-else statement. So everything I have outlined here will be skipped in this else-if statement. I'll follow this path, I'll skip the else, and basically the only line of code that executed here was the health equals health minus 8. That's what an else if statement does. An if statement is a one-way decision. An if else statement is a two-way decision. And the way I've designed this is I've designed an else if statement to be a four-way decision. I'm setting up one of four paths. 1, 2, 3, or 4 paths. And this code will only ever execute one of those 4 paths. So let's change the damage variable to 5 and rerun this same code. You can see I've updated the value of the damage variable to 5. So I have a completely different input to this else if statement of 5 in the damage variable. Health, I've retained the 92 in it. Let's see how it runs now. Damage contains a 5, so damage greater than 10 will evaluate as 5 greater than 10, which is very much a false statement. When the if statement is false, what do? We go to the else and follow this line. This if was false, so I'm going to execute this else. Well, what's immediately following that else? Another if statement. And in that other if statement, damage is greater than 6. I'm taking slightly less damage. 5 greater than 6 is still a false statement. Remember, if the if portion is false, I've got to go to its else. And there is an else immediately following this if. Tracing the code again, because 5 greater than 6 is false, I'll go to the next else statement. This if is attached to that else. If this if is true, I'm going to execute the statement immediately following the if. The statement immediately following the if is damage greater than 3. 5, which is in the damage variable, is greater than 3. That is very much a true statement. As a true statement, we know what it's going to do. It's going to execute the code in the if statement. 5 greater than 3 was true, so I'm going to execute a health equals health minus 2. My 92 just went to 90. You see what this code is doing? If I receive a lot of damage, I'll subtract 8. If I receive a moderate amount of damage, I'll subtract 4. If I receive a smaller amount of damage, I'll subtract 2. What happens after the if is true and we execute the code in the if? Why, we skip the else, of course. This if is attached to that else, so if this is true, I'm going to skip that else and continue on. See it? Pretty straightforward. I'm selecting one of 4 paths. In this particular case, I chose, or the code chose, to select the third option. Whenever I want to write code that chooses between 4, 5, 6, 7 different options, I can use an if-else statement like this. And each if will select one of the different paths. And when it selects the path, it will skip the remaining paths. Set damage equal to 2 and try this again. You can see I've updated the damage variable to 2. My health variable contains 90 again. This looks like code I'm going to run every time I get hit. Every time my player in the video game gets some sort of hit, either a punch or a bullet or some sort of damage, I'm going to run through this health, and depending on what hit me, I'm going to subtract more from my health points. You get shot, you expect to lose more points than if you got punched. And that's what this code is deciding. How big was the damage and what sort of consequences to my player's health points should there be? So 2 seems to be a small amount of damage. Let's see what happens when damage is 2. Damage greater than 10. With 2 in the damage variable, 2 greater than 10 is very much a false statement. As a false statement, it will skip the if block and go straight to the else. And here it is. It went straight to the else. This else is attached to that if. 2 greater than 6 evaluates again to a false statement. Damage is 2. 2 greater than 6 is false. When the if is false, I jump to the else. This else is attached to that if, so I'll jump to this statement immediately following the else. Damage greater than 3, 2 greater than 3 is still a false statement. As a false statement, I will jump to the else. I jump to the else that is attached to this if. See that if? The closest else is that one. I'm jumping to its else, and I will jump to this else and execute a health equals health minus 1. You can see my 90 changed to 89. If all 3 if statements were false, that's when this last else executes. This last else is sort of a catch-all. If all 3 of these ifs are false, by default, I will only subtract 1 health point. Remember, this is the code that executes when my video game character takes some damage. So I know when this code executes, something happened. If I get a large amount of damage, I subtract a larger amount from health. But if I get a small amount of damage, I only subtract a small amount from the health variable. There you have it. When I'm done with the else portion of the code, of course it will leave this code, and we're done with that code. That is the if-else statement. When you have a one-way decision, you use a simple if. You have two different choices of code to execute, you use an if-else. When you need to choose between 3, 4, 5, or more paths, select one of these different options. Use the else if statement. What we're doing is we're chaining another if-else to the end of if-else. So this one is changed to the initial if-else, and this one is changed onto the second if-else, and this final else is sort of our catch-all. It executes when none of these options are true. There is a competitor to the if-else statement called the switch case statement, sometimes just called the switch statement. Once again, like the else if, the switch case statement chooses between one of multiple paths. If I only have to choose between two options, I use a simple if else. But what if I had 3, 4, 8, 20 different options and I wanted to select one of many different options? That's when you use an else if, or you use this newer switch case version. We'll look at how it works by tracing the code. Start with weapon and a value of 1. What will this code do if my weapon variable has the value of 1 in it? With the value of 1 in the weapon variable, I'm going to switch on the weapon variable. When I switch on the weapon variable, I will compare the value in weapon to one of these many different cases. And really what I'm asking is, does weapon match case 1? Does weapon match case 2? Does weapon match case 3? When I get a match, I will select the code underneath the case to execute. So with a weapon value of 1 and tracing this code, case 1 matches weapon. Weapon has the value of 1, so weapon matches case 1. When we have a match between the weapon and the case, I will select that code to execute. Since we had a match, I will go inside the case 1 code and execute weapon name equals shotgun. You can see I've stored shotgun in my variable weapon name. That's it. When weapon matches the case, you execute that code. I will select one of 1, 2, 3, 4, 5 different paths. Just like the else if, what I'm doing is choosing one of these 5 different sets of code to execute. And since weapon matched case 1, this executes. After the weapon name equals shotgun, it will hit what's called a break statement, and that literally says break me out of the case. I found my match, I set my weapon name, I want to break out of the code. And what the break statement does is it follows this path outside of the switch. It literally means break out of the switch, and the code after the switch case statement will execute. See what we're doing here? We're selecting one of these 5 different paths to execute. Set weapon equal to 3 this time and make it follow a different path. Switch on the weapon variable, so what I'm really switching on is the value 3 because weapon contains a 3. What happens when we have a weapon value of 3? Well, first of all, case 1 no longer matches. Weapon, which is 3, does not match case 1. So this is a false statement. When it's a false statement, as you would expect, it's going to skip to the next case. So because case 1 did not match weapon, we'll go check case 2. When we check case 2, weapon, which contains a 3, matching case 2 is a false statement. It is not a match. Weapon does not match case 2. So as you would expect, we're going to skip case 2 and go to the next case. The next case happens to be case 3. The value in weapon does match 3. Weapon contains a 3. Case 3, it's a match. Since this is a true statement, it's going to execute the code in case 3. So weapon name equals Uzi executes. You can see my weapon name variable changed to Uzi. After I set the weapon name to Uzi, I'll fall down to the break statement. I'll execute the next code in the case statement. The break statement does, as we've already explained, break you out of the switch. I selected case 3 to execute. I will break and get out of the switch and continue on with the program after the switch case statement. See that curly brace down there? That is the end of the switch. The break will take you to the line of code after the switch, after that closed curly brace. Let's start with a weapon equal 99 and see what happens. Weapon equal 99 is none of these cases. So let's see what happens. I have the 99 in the variable weapon. I still have my Uzi from the last time this executed in weapon name. Weapon value is 99. So what I'm really switching on is 99. Compare 99 to all the different cases. Does 99 match case 1? Absolutely not. That is false. So I'll fall down to the next case and check case 2. Does 99 in weapon match case 2? That's a false statement. Once again, I'll fall down to case 3. Does the 99 in weapon match case 3? Does the 99 in weapon match case 3? That is very much a false statement. So I fall down and check case 4. Does the 99 match case 4? Absolutely not. That is false. So what's going to happen here when I have a value of 99 in weapon is it's going to hit what's called the default case. The default case matches everything. The default case says if none of these match, execute the default. It's kind of like that final else in the else-if statement. It matches everything. If my weapon number does not match 1, 2, 3, or 4, it will execute the default. When it executes the default, weapon names will go to fist. You can see there's my new value in weapon name. And of course, when it finishes executing that case, it continues on with the program and executes the code after the switch case. There you have it, the switch case, a direct competitor to the else if. I tend to go with else if I have 4 or 5 cases. But if I ever have a piece of code that has to choose between one of 10 options or 20 options, the switch case is a little nicer than the else if statement. I think that's my personal opinion. Wow, these are all selection or control statements. Is it clear? This switch case statement is selecting which code to execute. It's choosing or controlling the path the program takes. If my weapon is set to 2, it would take this path and then the break would take it past. Do you see why they're called selection statement? It's pretty clear here. It's selecting which one of these 5 options should this code execute at this point in time. And it's all based on the value of weapon, the variable used in the switch. Okay, let's look at something called the AND logical operators. Logical operators produce true-false values. Logical operators can be used in conjunction with relational operators. Remember what relational operators do. They compare 2 numbers and they return true-false. They provide an essential ingredient for selection statements, things like if else, and else if statements to determine which code executes. Well, what logical operators do is let us build more complex Boolean or conditions to decide how to execute which code in the if statement. This is the AND logical operator. When I have a couple of conditions, condition is a true-false value. Condition and Boolean mean the same thing. A condition is anything with a true-false value. A Boolean is anything with a true-false value. So what an AND logical operator does is let me string together or build more complex if statements to decide which code executes. So looking at the AND logical operator, let's see how it works by tracing the code. You can see I've built a much more complex if statement here by tying together 2 relational operators with an AND. Let's see how it works. Let's put the value of M in the rating variable and the value of 18 in the age variable. When I evaluate rating equal M, The equality operator here says M matches M. This is very much a true statement. Then I'll go over and evaluate the age greater than or equal to 17. Age contains an 18, so this is 18 greater than or equal to 17. That is also a true statement. Turns out both sides of the and are true. Well, that's interesting. The way I remember the and logical operator is it's all true to be true. You can see here in the truth table when both of my inputs to the and logical operator are true, when I and them together, I get a result of true. So when both inputs are true, I expect the and to return a true value. And sure enough, you and true together, and you get a result of true. Focus on this line of the truth table. If both my inputs are true, then the result of the and is a true logical operator. This here is called a truth table. It goes through all possible inputs of true and false for the and logical operator and tells you what the output should be for those two inputs. Remember, all true to be true, the only time the and produces a true result is when all the inputs are true. Let's trace this again with different inputs for rating and age. Set the rating for T for teen and the age to 17 and see what happens with this if statement and how it evaluates. First of all, our rating is T, so T equal to M is a false statement. After we evaluate that side, we'll go over here. Our age is 17. Age greater than or equal to 17 is a true statement. 17 greater than or equal to 17 is a true statement. So my input to the and is false and true. So when I and those two things together, what happens? I get a result of false. Look at this line of the truth table. False for the left operand, true for the right operand. All true to be true means this has to be a false. So we're going to output a false on the and. So this if portion will not execute. It's going to skip past the if block on the code. So there you have it. That's the and logical operator, and this is the and truth table. The way I always remember the and truth table is all true to be true. The only way an and will ever be true is if all its inputs are true, and that's what this line is showing you. If my first or left operand is true, but my right operand is false, then the and will output a false. If my left operand is false, but my right operand is true, then the and will output a false. And of course, if both inputs are false, then that result of the and will be a false. And simply means what the English language word and means. And means both have to be true. If you want to go to college at Stanford University, one of the best computer science schools in the country, you have to have good grades and high SAT scores. And the only way you're going to get in if both those things are true. So and means exactly like the English language word and means. You've got to have both inputs to be true for the result to be true. All true to be true. Next up, the or logical operator. The or logical operator means exactly like the English word or means. Or means only one has to be true. The only way an or is false if all the inputs are false. So let's trace the code again and see how the or logical operator works. Once again, or is going to be used between two relational operators or two true-false values to determine whether overall the if statement is true or false. So I've set up a couple of variables here. Paid user is set to true. Credits is set to 37. And let's run these values through our more complex if statement. Paid user is a Boolean variable. Whatever's in the Boolean variable true will be the result of this Boolean variable paid user. Credits greater than 100, 37 greater than 100 is a false statement, so the other side of the or is false. However, or is not so picky. Or only cares if one of them's true. Focus on this line of the truth table. If my left operand is true and my right operand is false, my output is true. So I have a feeling this or operator is going to return a true. OR only requires one side of the OR to be true. Since the left operand is true, the result of the OR is true. Overall, this if statement is true, and it's going to execute the code in the if block. Let's try it again with different values in the variables. You can see paid user now contains a false. You can see credits contains a 91. A different input. I expect this code to evaluate differently. First of all, the Boolean variable paid user is returning a false. That's not going to kill us. We still have the other side of the operand. Credits greater than 100. 91 greater than 100, however, is a false statement. Now we see that both sides of the OR are false. What do we expect to happen? If you OR together two falses, look at this line of the truth table. False, false produces a false. That's my memory trick for remembering the OR logical operator. All false to be false. The only time an OR is going to be false is when both inputs are false. If any input is true, then the OR will produce a true. But if all the inputs are false, the OR will produce a false. This OR rightly returns a false. Both sides of the OR logical operator were false. So that is the OR logical operator. It does exactly what the English language word OR means. One input has to be true. If your mom says she'll buy you a video game if you clean your room or wash the car, she only expects you to do one. Clean your room, doesn't matter whether you wash the car or not, mom's buying you that new video game. Let's move on to the next logical operator. This one is not as popular as the and or, but let's look at it anyway. It's called the exclusive or logical operator, and it works like the and or, where it compares two input and returns true false. And logical operators return true false values just like relational operators return true false values. In the case of the exclusive or, what does the word exclusive means? It means I want a small number or just one. So I want one OR to be true. Exclusive OR means I want one of the inputs to be true. We'll trace it and see how it works. We'll set 14 in the rank variable. We'll set 27 in the weapon value. And rank greater than 10 is a true statement. 14 greater than 10 is true. 27 in weapon value is greater than 20. 27 greater than 20 is also a true statement. So in the case of this exclusive OR operator, both my inputs are true. However, if you come up here and look at this line of the truth table, when my left operand is true and my right operand is true, exclusive OR produces a false result. So when I trace this code through, I get a false. My memory trick for exclusive or XOR is different, true, same, false. If the two inputs are the same, both true, I output a false. If the two inputs are false, the same, I output a false. The only time exclusive OR produces a true result is when the inputs are different. When I have one true input, I will produce a true output. That's exclusive OR. Let's start again and let's put some new values in rank and weapon value and see how it works. I'll set rank equal to 6. I'll set weapon value to 21 and see how it works. 6 greater than 10 is definitely a false statement as the left operand. Wep value 21 greater than 20 is definitely a true statement. 21 greater than 20 is definitely a true statement. So my inputs are false and true. Looking at this line of the truth table, false and true produce a true value. So when I evaluate the overall if statement, false, exclusive, or true produces a true result. As a true result, whatever code is in the if block will now execute. There you have it. Those are our three logical operators, and, or, and exclusive or. I think the most important thing to remember is logical operators take two logical values as input and produce a logical value. They produce the same true false values we use in an if statement, to decide whether we're going to execute the code in the if block or the code in the else block. That's it for this lesson. We'll see you on the next one.